In case of multiphase flow, we have to first set the solver. We are going to use InterFoam. This we can keep as is. We'll change if we require something. This we don't require anymore. Now what we'll do is we'll run InterFoam. Why we are doing this? Because we want to check what else do we need. First of all, in the patchField point displacement, we have to fix all the boundary conditions. Here, let's make this walls for all the walls. These point field we don't require anymore. We can remove this. And in the dynamic mesh dict, we just need the refinement. We don't need any motion. Let's remove this motion and we'll just try dynamic mesh. And now for pressure and velocity, we have only two values, walls and atmosphere. For the atmosphere, we need pressure, inlet, outlet velocity. We'll set this to uniform 0, and all our walls are no slip walls, and velocity is 0. In case of multiphase flow, we don't have pressure. Instead of that, we have modified pressure, which we call prgh. This we are going to keep uniformly 0 everywhere, and for the walls use fixed flux pressure, and for this we are going to use the phi as phi absolute. The value we are going to take as uniform. For the atmosphere, we are going to use total pressure, and we are going to use P0 as uniform. Apart from this, we need alphawater. Alphawater is the value which tells it that which domain is water and which is not. For this, we have to set this using setfields, but to start with, we should have some values defined. We'll use these particular values, everywhere 0, and we'll use setfields to set these values. Let me create the setfields file. In the setfields dict file, which looks something like this, you have to define a default value which will set the value of alphawater in each and every cell center, and then you can use various methods to set the value to certain region. We have used this particular region. We are using this method box to cell. Here you have to define a box. You can define by just telling it 2 points which are diagonally opposite along the face. The first point is the corner point of the domain, and another point is somewhere in the middle. This we can set as 0, 0, 0.5, 0.5 to make it a little bit interesting along the z direction. This is fine. Here we will set the value equal to 1. Then in the schemes, we need some extra things that we are solving. For example, we should have rho phi u and the solvers for alpha and the solvers for alpha, and then for k and omega as well, but we are not going to solve any turbulence model. Our turbulence model is lambda. We don't need that. And here we should have a solver for alpha as well. We will add that. Instead of P, we should have prgh. Similarly here, P final, we should have prgh final, and nothing else is required. Since we are solving using Pimple, we can also have one more parameter, which is C alpha, which is by default set to 1, but we can decrease this value to make the interface between two phases sharper. Once this much is done, we can try solving this. We have done the block mesh. After that, we have to do set fields. Set fields will set the fields for this alphawater, and it has set these values in the entire domain. And then we can run InterFoam. There are some problem. Let's see in the atmosphere, 0u atmosphere. We missed this semicolon here. One more thing is in the transport properties, we should have instead of just one nu, we should have phases. Let's set that as well. So these are the phases. We have two phases, air and water. We don't have to do anything for air because wherever we don't have water, we have air. Sigma is used for the surface tension effect if we have a bubble or something like that. Then let's try running again. We need G value. We can set the G value. Let's create this. We can make it along Z direction. Let's try running. There is some problem with the field pressure, don't have a correct value. When we are doing prgh, which is the modified pressure, we should have a different dimension, which is this. Now let's solve. Solve are not found in the dictionary for these two. We have to remove one of them. This is for RGH. And this is something which is required. We have to go to the controldict and set this to say 0.1. This is the current number for max alpha. This we are setting as 0.1. In the fvSchemes, we missed this one as well. We have not saved it. After saving, and this is something which is different. Let's copy this and use this as well. For this as well, we are going to use Gauss linear. Now it's running. This is how you can read the errors and improve your setup for OpenFOAM.